This is the Chapter 7 test review, and I am going to be doing the odds. Alright, so for the first one and the third one, name the vertex of each angle. So the vertex of angle 5, right there. So the vertex would be angle M. Then for number 8, so that's just right there, the vertex would be angle O. Write another name for each angle. I could do angle P. I could also just switch it up and do angle RPQ, just doing it backwards. Number 7. In the figure, CB and CD are opposite rays. CE bisects, so this right here bisects this angle, and this one bisects this angle. So put that in perspective. That's an angle bisector, and that's an angle bisector. So what that means is this angle, oh goodness, this angle is going to equal this angle, and this angle is going to equal this angle. So it says our first problem wants us to find DCE. So if DCE, so that would be this right here, if that's equal to 4x plus 15, and measure ECF, so that would be what it's adjacent to, is equal to 6x minus 5. We gotta find DCE. So remember how I said before that this angle has to be equal to this angle because of this angle bisector here right in the middle. So what I would need to do is just set these two equal and then solve for x and plug it back in. So it'd be 4x plus 15 is equal to 6x minus 5. So then 2x is going to equal 20. X is going to be equal to 10. And then I'm just going to plug that in for what DCE is. DCE is 4x plus 15, so 4 times 10 plus 15. 40 plus 15, so that measure DCE is equal to 55 degrees. Find the measurement of each segment. Assume the figure is not drawn to scale. So for PS here, it looks like all you would really need to do is that if you're looking for a PS, let's just add these two together. So I'm going to do 18.4 plus 4.7. It's going to be 23.1 centimeters. And remember, it's just this portion, small portion, plus this small portion equals the whole thing. For 11, we're looking for this little portion right here. And what you could do if you really wanted to is label this X, but the easier way to do it would just be that we're looking for this portion right here. So why don't we take the whole thing and then minus the 89.6. So I'm going to do 100 minus 89.6. And that'll be 10.4 centimeters. 13, find the value of x if KL is, and KL if K is between J and L. So Let's just draw this out. So it looks like J, K, L. Now it doesn't tell us that it's the midpoint, it just says it's in between. So if JK is equal to 2x, KL is equal to x plus 2, and the whole thing is equal to 5x minus 10, all we would need to do is say this plus this is equal to the whole thing. So 2x plus the x plus 2 is equal to 5x minus 10. So again, the small part plus the small part is then equal to the big part. So I get 3x plus 2 is equal to 5x minus 10. 2x on this side is equal to 12. X can be equal to 6. So it says find the value of x. We found the value of x. X equals 6. If you wanted to, you could plug these back in just to make sure you're right. 15, name a linear pair with the vertex B. So B is right here. So I need a pair of angles that are a linear pair. So remember, it has to share the same line. So it looks like the best angle for me would be to do this angle here and this angle here. So that would be angle GBC, and then angle C, let me redo that, angle CBA. So what we see here is that they share this same line right here, and that makes, they share this line right there, and the vertex is B for both of them. We're good to go. Name an angle adjacent and supplementary to DCB. So DCB is right here. It's got to be adjacent and supplementary. So remember, supplementary is equal to 180 degrees or just a flat line. So DCB, it looks like the only side that angle shares with another angle is this one right here. So while there could be different answers, we just know that this right here is going to be what makes it supplementary and adjacent. So while there could be several answers, it could be DCF. If you flip that, it could be FCD, but then you can also incorporate the H here. So you could do like DCH or HCD. 19, two angles form a linear pair. So let's just say it's like that. One is 7x minus 9. The measure of the second angle is 16x plus 1. So that's what's given to us, right? But we need to assume, since it's a linear pair, that this right here is equal to 180 degrees. So what I would need to do is I would need to add these two angles, so this angle and this angle, and then set it equal to 180 degrees. So 16x plus 1 plus 7x minus 9 is equal to 180. So then that would be 23x minus 8 is equal to 180. 23x, 170. Oh, sorry, 188. So do 188 by 23. I have to get a decimal here, so let's just double check our work. 7x minus 9, 16x plus 1. It's going to equal, so let me double check my work here. So that would be 23x minus 8 equals 180, so 188. 188 divided by 23 is going to be 8.17, so x 17. Let me know if I did that one wrong. Then we go down to 21. If BCG, not BCG, BGC equals 16x minus 4, so B right here, 16x minus 4, and then CGD, so the one that's adjacent to it, is equal to 2x plus 13. Find the value of x so that the entire thing, this and this, is equal to a right angle. So we know a right angle equals 90 degrees. So the only thing I'd have to do is add these two up, set them equal to 90 degrees. So I would have 16x minus 4 plus 2x plus 13. And then all of that combined is going to be equal to 90. So it would be 18x plus 9 equals 90. I'm going to minus the 9 on each side, so 90 minus 9, then I'm going to divide by 18. So x is going to equal 4.5. And that's for number 21. All right, for 23 here, determine whether each statement can be assumed. So is this true or false? SRQ, so this angle right here, and QRP, so start with right here, QRP are linear pairs, so we have to decide, is that a straight line? That is a straight line. And then, right, do they have an adjacent side? Yes, they do. So you would just say yes. They form a linear pair because they have an adjacent side and they equal 180, or they are supplementary. 29, name a point contained in line Q. Line Q is right here. So I just got to name a point, so point B. 31, name the plane containing lines N and P in two different ways. So N and P, where is line N? Line N looks to be this line right here. Line P equals this line right here. So we just need to name this plane right here in two different ways. So I could name it by just listing off 3 points. So plane, let's just say CAB. But then you can also see down here, there's that little G right there. And it's in kind of like that italics, so you could say plane G. 33. Plane plane J contains line V. Line V contains point A. What's going on with this one? But not B. Okay, so this one's kind of a tricky one. Plane J, did that wrong again. So I just draw plane J. Contains line V. Okay, so I got this right here. Say this is line V, and then it contains point A, but it doesn't contain point B. 35, lines Q and F intersect at point D in a plane U. So let's draw a plane. We'll call it U. Q and F. So those lines intersect, and they intersect at point D. 37. Name two planes that contain the points E and D. So E and D, so I'll probably do this plane right here. So that would be plane FDE in any order, just those 3 points. But remember, a plane has to have 3 points. And then also, this plane right here contains both E and D. So I could just say EDC. I could also do BED. That would also be acceptable. So just remember there's several lines there. 39 are points A, B, and D coplanar. So coplanar meaning are they on the same plane? So A, B, and D, are they on, and is there any flat surface that they're all on the same? I would say no, because they're not all on this W here. And A and B are on this one, as well as this one, while D is on that one by itself or the one in the back. So I would say no. All right, use the number line. So T to V. Got to find out how long this is. So it starts at -4. Each one of these hash marks is 1. So this would be 1, 2, 3, 4, 5. So this would be 5 here. SV is going to be, let's see, did I mark over that? No. So starts here, and we go 1, 2, 3, 4, 5, 6, 7, 8. All right. Find the distance between each pair of points. So I have a point here, I have a point here. S is going to be 1, 2, 3, 4. So S is going to be 4, 4. So we're just finding the coordinates. And then E is going to be 1, 2, 3. So -3. And then down 1, 2, 3, 4. Okay, so you could do that, or you could do it the simple way, which would be just to draw this triangle here, right? So if you wanted to, you could take these numbers right here and put them in the distance formula. What you could also do, which might save you some time, is just draw this triangle and then count these numbers. So this would be 1, 2, 3, 4, 5, 6, 7, 8. So this side's 8. This side is 1, 2, 3, 4, 5, 6, 7. So Pythagorean theorem says 7 squared plus 8 squared is going to be equal to C squared, and we know that C is right here. So 56 plus 64 equals C squared. 56 plus 64 is 120. It's equal to C squared, but I'm just looking for C. So I'm going to take the square root of both of these, and it's going to give me 10.95 is equal to C. All right, so we know the distance formula. So if I'm done with the graphing part, we know that the distance formula is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. So in 47, I have my first x and my second x, my first y and my second y. So all I need to do is take those and plug them in to wherever they need to be in the distance formula. So I'm going to get the square root of 4 minus 1 squared plus 4 minus 3 squared. If I simplify that, 4 minus 1 is 3, and I square that, that's 9, plus 4 minus 3 is 1 squared. It's going to be 1, so I'm looking for the square root of 10. I take the square root of 10, I get 3.16. And then I would do the same thing for 49. So I'm going to do the square root of 8 minus a negative 2. And I'm going to add 8 minus a negative 1 squared. So then if I simplify that, that would be square root of 8 minus a negative 2 is 10. Squared is 100. Plus 8 minus negative 1 is 9. Squared is 81. So the square root of 181. That's going to need a calculator for that. 13.45. That would be your final answer. All right, so we go to 51. Use the number line to find the coordinate of the midpoint. So QR. So I know this is 1, 2, 3. So it's 1, 2, 3. It's 4 total spots, right? So if it's the length of it's 4, I would just go to 2 spots over. And I would find that my midpoint's right there at negative 4. Alright, so I just did 51. Not going to do 52. Find the coordinates of the midpoint of a segment within the given points. Remember, the midpoint is x1 plus x2, so just add the x's over 2. And then y1 plus y2, just add the y's, divide by 2. And that's your coordinate. So I'm going to add the 12 and then negative 8. So negative 12 plus negative 8 is negative 20 over 2. Then we have negative 7 plus a negative 4, which would be negative 11 over 2. I can reduce this or simplify it. So negative 2 divided, or negative 20 divided by 2, it's going to be negative 10. And then I could keep negative 11 over 2, or I could just make that into a decimal. So negative 11 divided by negative 2 is negative 5.5. All right, that looks like it's it for me on those. Email me if you have any questions. The test is on Thursday. And then if I got any of these wrong, let me know. All right, guys, have a good day.